welcome to qiphyedu. Today we're looking at computer science A2 level, paper 31, October-November 2021. Alright, let's start. Okay, so for the first question, it says numbers are stored in the computer using floating point representation with 12 bits for the mantissa, 4 bits for the exponent, 2's complement form for both the mantissa and exponent. Then the first question, 1i, it says write the normalized floating point representation of the following unsigned binary number using the system. So let's take a look at how many bits are there in this particular number. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then here there's only 12 bits for the mantissa. That means that we'll be taking we're taking the values on the left. Okay, we're taking the values, all the values on the left. And you need to remember that this one is unsigned. So that means that since it is unsigned, this means that it is not negative. This one is positive. Because unsigned means that it's completely positive. There's no way it's negative. So this one, you need to add a 0 to the front. So when you add a 0 to the front, that means that in this case, right, there'll be 14 bits. That means that 2 bits at the back will be omitted. Therefore, you're only left with 0, 1, 0, 1, 1, 0, 0, 0, 1, 1. So now let's just write this down into our mantissa. Okay, so now let's see where's the dot position. It's here, and then we need to start from the most significant bit and the second bit. Between that, the dot will start from there. Then we need to move all the way to this point and see how many bits we have to pass through. So that'll be 1, 2, 3, 4, 5, 6, 7. So there'll be 7, which will be 1, 1, 1. So here exponent would be 0, 1, 1, 1. Because 2 power 0 plus 2 power 1 plus 2 power 2 equals 7. So that's why that's the answer. But here, because of the fact that we have omitted 2 bits at the back, that means that we have truncated the 2 bits at the back, resulting in inaccuracy. So here you realize that the next question will be, state the consequence of storing the binary number in part A1 as a floating point number in the system, and we need to justify the answer. That means that then we need to write out the consequence, which is reducing accuracy. Reduces accuracy as the 2 bits of the right most, because we just put 2 bits on because the 2 bits on the right as the final 2 bits on the right are truncated. And then justification is original number. Actually, the final 2 bits on the right are truncated. This one is the justification, but we're just making it so that the consequence looks much complete. And then justification, we can also say that original number has 13 bits, but the mantissa can only store 12 bits. Okay, then B, we need to explain the reason why binary numbers are stored in normalized form. You need to remember that 0 here is to show the positive or the negative, to show whether the number is positive or negative. So by doing this, we'll be able to show the maximum number that is able to be stored in normalized form. So we can just say to store the maximum range of numbers in the minimum number of bytes, or the minimum number of bits. It also minimizes the number of leading zeros. Because if you can see in normalization, it always starts with 0 and 1. But you won't see mantissa being 0, 0, 0, then only then you get a 1. That's not possible in mantissa. You need to always remember that if this is the case, right, all the zeros will be pushed to the left, except for the first bit. So that means 3 zeros be gone, only left. This one would then be the ones left in the mantissa. Alright, so number leave zeros, and then maximizes number of significant bits. Not only that, it enables very large numbers to be stored with accuracy. Right. 2. Draw one line for each programming paradigm to its most appropriate description. Declarative is basically specifying the desired result. Okay, it just specifies the result, so it just gives you the result basically. It just gives you the answer. Then imperative is when it has an explicit sequence of commands that will update the program state. So this one will be under imperative. Low level is just instruction set processor, for example assembly language. And then object oriented is like includes classes, encapsulation, polymorphism, inheritance, all those. Right, like this one. So this is the answer. Then 3, enumerated and pointer are two non-composite data types. Write pseudocode to create an enumerator type called parts to include these parts sold in the computer shop. So let's put in type, then parts equals monitor, CPU, SSD, HDD, laser printer, keyboard, and mouse. Okay, and B, you need to write pseudocode to create a pointer type called select parts that will reference the memory location in which the current part name is stored. Okay, so type select parts equals, we need to remember to have this arrow because it's the memory location, so we can put parts. Alright, then for number 4, alright, let's look at A. Write the Backus null form notation of the syntax diagram for character. So Backus null form syntax character. Okay, so this one will be character, and then 2 colons and 1 equal, and then we have 5 options here: the $, percentage, ampersand, the multiply symbol, and hashtag. Okay, these 5, and then a password must begin with a character and be followed by one or more digits of capital letters. So we have capital letter, which is A, E, I, O, U, and then 0 to 9 for digits. Begin with a character. Character would be, okay, I'm just gonna put percentage as an example, followed with one or more digits of capital letters, one or more digits of capital letters. It could be, okay, so let's say 2U3A. This is an example. Then a valid password is represented by the syntax diagram. Write the Backus null form notation of the syntax diagram for password. So here what we do, just put password, 2 colons and equals, then character. Okay, then here is where it's a bit difficult. You put character, then it's then, you remember that this one is character, and then what you can do here is you can then separate this part and this part, right? Make it much easier. So then we can just name it as code. So for code, we can do something like this. You can do digit, and then you're done. Or you can do digit, and then you can keep on with the code. or you can do digit, or you can do capital letter, and then code, or you can do capital letter only. Okay, so you can see essentially what I'm trying to do here is that you can see that digit is the first one in front, because code here, it could mean digit, it could mean digit or code, which means that it's just repeating itself. Okay, it's repeating itself. Capital letter can repeat itself by digit, can be 1 digit or 2 digit, or you can also do capital letter, which is only one basically. So yeah, one character and one code, which is 1 capital letter, or it could be 1 digit or 1 capital letter. That's how I show it in Becker's null form. Alright, and then for 5a, we need to compare sequential and serial methods of file organization. So both of these, there's one similarity in both sequential and serial methods of file organization. Records are stored one after the other, and needs to be accessed one after the other. By writing this sentence, you already get 2 marks. Why? Because 1 mark goes to here, second mark goes to here, right? Goes here, and then next one you can say that serial files are stored in chronological order, basically just in order, like A, B, C, D, 1, 2, 3, 4. Whereas sequential files are stored with ordered records and stored in the order of the key field. And then in serial files, I actually mentioned that chronological order is like A, B, C, D, but actually it's chronological order as in it's basically like first come first serve. So like if let's say you have file A that goes into the record early, then let's say file B goes in like 5 minutes later, then you'll go to the second space. Yeah, so something like that, but not A, B, C, D. It's because it's chronological order as in time, like first come first serve basis. And then in serial file, new records are added. Are added in next available space. Whereas for sequential files, new records are inserted in the correct position, because it's based on the key field. Alright. Then state the most suitable method of file access when a record is referenced by a unique address on this type storage medium. That will be direct access. And then for most suitable method of file access when a bank stores data in ascending order, that will be sequential access. In 6a, explain how packet switching is used to transfer messages across the internet. You say that data is split into packets. into packets, so you can say, if you want it to be more detailed, you can say it's split into smaller chunks known as packets. The packet has a header and payload. The header contains both the source and destination. IP addresses. Each packet is sent independently through multiple routes or through different routes. And may arrive and may not arrive in order at the destination. Okay, that's how you get 5 marks. This one is the first mark, this one is the second mark, this one is the third and fourth mark. Third mark, and then you get and then this one is the fourth mark, and this one is the fifth mark, and then sixth mark. Alright, if you want to make it more complete, you want to add the final touch, you can also say that if the packets are corrupted or missing, a retransmission request is sent so that the packets will come in order and is completed. Okay, so that's how you're downloading files work nowadays. And outline the function of a router in packet switching. It examines the packet headers, packets header, sorry. And reads the IP address of the destination, or reads the destination IP address. It also has access to a routing table, which contains information about gateway use and the status of the routes. Right? So examines packets header 1 mark, reads destination IP address another mark, has access to routing table 1 mark, contains information about gateway use is 4 marks, and then status of routes will be 5 marks. Right? Then move on to 7. Write the Boolean expression that corresponds to a given truth table as the sum of products. Okay, so so if you look at this one you need to calculate based on the available output that shows a 1. So everything that's 0 can be ignored. So everything here, just ignore it, and this one also ignore it. So here we have A, not B, not C, and D. So you can also ignore the dot if you want to, but I'm just going to put it there just in case. And then plus, which is all. So all you can put A, then this one is not B, then C, then D, then plus A dot B dot not C dot not D, and plus A, B, not C and D, plus A, B, C, not D, plus A, B, C, D, right? So that's that. And we need to complete the Karnaugh map for the given truth table, so we need to look at the expression. So A not B not C not D is basically 1 0 0 0. So 1 0 0 0 would be here, and then A not B C D is basically 1 0 1 1. So 1 0 1 1 is here, and then A B not C not D is basically 1 1 0 0, which is here, and then A B not C D is 1 1 0 1. So that will be here, and then A B C not D is 1 1 1 0, which is here. Yep, 1 1 1 0, and then A B C D is 1 1 1 1, which is here. Okay, which means that okay, I think I make a mistake. Let me look back at the ABCD one. So ABCD. Oops. D is actually D, not D. So it's A, not B, not C, D. Alright, I just realized the 1 0 0 1 here. Okay, so we need to move this down. Okay, move this down, and then here we put all zeros because it's not included in our expression. Okay, and then now we need to complete a sum. We need to draw loops around the appropriate groups of ones in K-map to produce an optimal sum of products. So of course the first one will be this one, the second one will be this one. Okay, so what will be the sum of product for the vertical 4 numbers here? That will be AB. Okay, that will be AB. Then we need to calculate the sum for the second circle here. So first we put AB. Then the sum of circle here would be, okay, the ones that are similar, that has similarities here would be A and then D. So AB plus AD. Okay, then now we need to write the simplified Boolean expression. So that will be A, B plus D. Alright, so that's the answer for this. And then for 8a, we need to describe the purpose of the secure socket layer, secure sockets layer and transport layer security protocols. So basically it's to provide security over the internet. So it protects your data over the internet. So SSL and TLS protocols provide communication security over the internet by providing encryption, both of these protocols enable two parties to identify and authenticate each other and communicate with confidentiality. Confidentiality, so LITY. Right, so this one is already 4 marks because provide communication security over internet 1 mark, providing encryption 2 marks, enables two parties identify and authenticate each other 3 marks, and then communicate with confidentiality 4 marks. And B, explain how SSL TLS protocols are used when the client-server communication is initiated. So an SSL/TLS protocol connection is established. Sorry, it's not established, but it's initiated. Or initiated by an application which becomes the client. The application that receives the connection becomes the server. every new session begins with a handshake. Then the client requests digital certificate. From the server and verifies the digital and verifies it. It then obtains the server's public key. And the encryption algorithms are agreed. Okay, so basically, step 1, an application will have to initiate the SSL TLS connection, which will then become the client, and then the application that receives the connection becomes the server, and then every session would then begin with a handshake protocol. It will begin with a handshake, and then the client will then request the digital certificate from the server, and then verifies it. After it's verified, it will obtain the server's public key, and then the encryption algorithms would then be agreed on, and that's how an SSL TLS protocol is initiated. Alright, then for 9a, the diagram shown represents an artificial neural network and state the reason for having multiple hidden layers. The hidden layers in an artificial neural network would allow for deep learning to take place. So let's say allows deep learning to take place, because that's exactly what deep learning is about, to have multiple layers. You can also say to improve accuracy of result. Explain how artificial neural networks enable machine learning. So artificial neural networks can replicate a functional human brain. And you can say the weights are assigned for each connection between nodes. For deep learning, the data would be input. Data is input at the input layer, and pass into a system. It is analyzed at each layer, each subsequent layer, where characteristics are extracted this process is repeated many times to achieve optimal output. So this is something like reinforcement learning. Reinforcement learning is something like a reward and punishing system where you do trial and error to see which one will give you the best output. So this is the same for deep learning. Deep learning is the neural networks will try to mimic the human brain, and then weights are then assigned for each connection. Then the data is input at the input layer, and then it goes through subsequent layers. so that its characteristics are extracted, and then the process is repeated many times to allow the output to be achieved at an optimal level. Alright, so with that, it's already 1, 2, 3, 4, 5 marks, right? Right. So then you can also say that decisions can be made without being specifically programmed. And you can say the output layer provides the results. So here you can also say the output layer provides the results. Okay. And for B, you need to find the shortest path between the home and school nodes using the A-star algorithm. Show you're working in the table provided, the first two rows in the table having completed. So it's from home, let's get 0, heuristic 14. And then A is 1 and heuristic 10. Now let's do C. Okay, C, the cost here would be 4. Heuristic would be 9, so you get 13. And then now we try B. B would be 5 and 7, so that'll be 12. Okay, so that means that the shortest one would be from home to A, and then from home to A we can then try B again. This one will be from home to A to B, so this will give us cost from home will be 4, and then heuristic value will be 7, and then we will get 11. Okay, so with that we can then jump to E, because we already know, sorry, not jump to E, but we need to calculate E. Okay, you calculate E, that would be that will give us cost would be 7, our heuristic would be 3, so total 10. And then we can calculate F. The cost from home would be 8, and then the heuristic would be 3, so it gives us 11. And then we can calculate school, which would be 11. Which would be which would be 11, and then the heuristic would be 0, we get 11. Or we can directly jump from E to school, which will give us a cost of let me check, 7 plus 5, 12. Heuristic of 0, so we get 12. So the shortest path to get from home to school would be from home to A, then to because CB is basically too long, you can see that if it's from home to A to E, then to school, to F to school would be much better, because from home to A to E, shortest heuristic value, and compared from directly going to school, you just jump from E to F, A to E to F. Okay, and then because of the lower cost, and then from F to school we get 11. So yep, so the shortest path would be home to A to E to F to school. Right, so you calculate based on the total value. So let's say you can see here, home to A is basically 11, and then C, B, and B are all too long, so we just jump to E. E will give us 10, F will give us 11, compared to directly going to school, which is 12, and then finally school. Right. Then 10a, we need to state the 3 essential functions of recursion. It has to have a base case and a general case. A base case would be a stopping solution condition. Then must have a general case. Which calls itself. And then once the base case is reached, unbinding can occur, taking the values back from the general, values from the general case basically. So unwinding can occur once base case is reached. Alright. Then B, explain the reasons why a stack is a suitable ADT to implement recursion, because it is a last in first out structure. Each recursive call, instead of Q you use stack, because Q is FIFO, stack is LIFO, so each recursive call is pushed onto the stack. And popped as function ends. This enables backtracking to maintain the required order. Okay, then C, identify two LEDs other than the stack, Q, like what I mentioned just now, and linked list. Okay, then D, the function stack full checks whether a stack is full. The function uses the variable top of stack to represent the pointer to the most recent position, and the variable max represents the maximum size. Assume top of stack and max are global variables. An algorithm add an integer is required to add a new integer data element to a stack. The stack is implemented as an array stack. The function add integer calls stack full and returns an appropriate message, and we need to complete the pseudocode for function add integer. So if let's say the stack is full, then it will return true, right? So here we need to use an if statement. So if it's full, then we can just directly say return the stack is full. If not, here the add integer required to add a new integer data element to a stack. So most recent position, so we need to change the top of stack to the higher position. So something like this, top of stack plus 1, and then we have an array. Array here is array stack. Then the boundary here, not the boundary but the number will be top of stack, and then we'll put in our new integer, and then it has to return an appropriate message. We'll just say return integer added or item added, and then an if, and then we can end the function. Okay, so then that's the pseudocode, and also this is the end of this paper. I hope you guys find this video helpful. Do share this video out to other people who may need help with computer science A2 level. As always, I hope to see you guys again in the next video. Till then, this is qiphyedu. Goodbye.